Denominators with quadratic factors is what we are going to handle next. But please, these quadratic factors should be unfactorizable, because if they are factorizable, we saw that we can treat them as linear factors. So please don't forget to subscribe to the channel. Now, to handle these ones, we say you look at them. We say if the factor is linear, the power, the denominator is going to be a constant when we are partializing it. And if it's quadratic, it means that the power is going to be linear, because we say always should be proper, so it should be a power less. Now, the first check, is this factorizable? No, because it's an x squared plus 3, you cannot factorize it, because if you try to solve this, you are going to get complex roots. So what we do, I'm going to handle this too, this and this, then we will handle this as we exercise. Now, to handle this now, we say 5 minus 3x over this. You see, this is linear and this is quadratic. Now, if it's quadratic, this is how we express it. So we say let this be, and then we can equal to, this is linear, so we say linear, we say a over plus that, then plus. Now this is quadratic. If it's factorizable, you handle it as linear. But this is unfactorizable. So we say you get the numerator to a power less. The one to power less, if this is x squared, means that the one which is going to be up is going to be linear. So it's going to be in the form of bx plus c over this x squared plus b. Why? Because if it's power 1, this is x power 0. If it's power 2, this is x power 1. So already this one is less with a power to this. Then we handle our, now we're going to mark. So you get the LCM, the LCM is this times this, which is here. So now my 5 minus 3x is going to be, now a into, you get this, you set this goes here, so you get this divided here, this is the one which is remaining, x plus 3, then plus bx plus c into, when you get this and divide here in the LCM, you see this will go and remain with x plus 1. As simple as that. Now you get the idea. To get this, you get the factor is not here and equal to 0. So that this is not here. So when I equate this to 0, so it's that when I equate x plus 1 to 0, so that our x is going to be negative 1. Put here negative 1, we have 5 minus 3 into negative 1 equal to a into negative 1, but remember we are squaring it, plus 3, then plus the whole of this is 0, then plus a 0, because the whole of this is 0. So here we are going to have, this is going to give us positive, so we have 8 equaling this is, when you square negative, you get 1 plus 3, which is 4a. And so that from there, our a is going to be a 2. So after getting a, now we have a, now we have 3 unknowns, a, b, and c. So now to get c, I remove this. If you remove this, this is already known. So we remove this. How are you going to remove? You see, if we say x is 0. So if our x is 0, if x is 0, these ones are my gains. So you see, to get c, I don't want this because this is known. So I have now simultaneous equation. two unknowns. It means I need to remove this. So if I remove this, to remove it, you see that I should get this as a 0. So if x is 0, I'm going to have now 5 equaling 2. This will be 0. So here we have 3f. Then plus, I have this 0. This will be now in c. So this one is going to be 0 times plus 1, which is 1, and c, which is going to give you a c. I make sure this disappears, but when I'm remaining with my c, that's that orange. This one is easier to equate it to 0. But I know my a is 2 from here. So I have 5 equaling 3 into 2 plus c. And from there, start my c is going to be, and take this side, get negative 1. So this is going to be 6. Take this side, get negative 1. So now I have also c. So now I'm ending with b. So here to get b, you can use the smallest you can get. So you can say when x, I can't get it to 0, so you can say when x is the 1. 1, when you put here 1 out, it's a very easy value to use. So when x is 1, so here I choose 1, you can choose 2, you can choose any. That's going to give you good signs. So when x is 1, so I have 5 minus 3 into 1 equaling 2. Here I'm going to be having a into a 4. Then plus b, x is 1 plus c. When I put here 1, I get a 2. So that I have a, I have c, I just want to there. So here, this is going to give me a 2 equaling 2. My a, remember my a is 2. 2 times I get 8. Then plus 2 times this I get 2b. Then plus 2 times c. But my c is a negative 1. Because c is negative 1. So c is 2 equaling 8 plus 2b minus 2. So you see, this is going to give me a 6. When I take this side, I have negative 4. And so that my b would be negative 2. If I simplify in that state, as simple as that. Now, after you come and rewrite this, so my 5 minus 3x, the whole over is equaling to our a is 2 over x plus 1 plus our b. Our b, we've got negative 2. Negative 2 into x plus c. Our c, we have got a negative 1. So minus 1 over x squared plus 3. Now, so this one is not yet in a partialized form. So you remember this is a denominator to this and this. So you separate also. So our 5 minus 3x. You can go on to simplify this to this. Because in integration, you'll find life easier if you are separating these two. Then this divided by this, I get negative 2x over x squared plus 3. Then this is negative 1 over x squared plus 3. And so this will be partial derivative in integration, and this will just use the time substitution. So see that now I've partialized it all. Why? Because if you have 1 plus 2 over 4, this is the same as this denominator is to both 1 over 4 plus 2 over 4. That's what I've been using here. So this is to this. So this goes here and also goes there like this. And here you are done with this number. When I come down to numbers part B, we have 6 minus 9x over 27x cubed plus 8. Is it proper? Yes. Why? This is degree 3, this is degree 1, so this one is greater, so there is proper. Even this was proper because that the whole denominator, its degree is 3. This one is degree 1, which is proper. So even this is proper, so you can handle it. But you see, can you factorize this? Yes, so this one you can express this as a cube and this as a cube. And remember that whenever you have a cubed minus minus b cubed, we get a minus b, a squared plus ab plus b squared. Note this is ab, not 2ab. When I have a cubed plus b cubed, this will be the same as, if it's plus, then this one is going to be a plus b. Then a squared minus, if this is plus, this sign is alternating with that. So if this is minus, this is positive. This is positive, this is minus. As simple as that. Note, this is AB, not 2AB. Some people make a mistake there. You try, when you expand this, I'm sure you are going to get this. When you expand this, you are going to get this. So, that's how we handle these ones. So now, so our 27, this 27 here. So my 27 x cubed plus 8, I can write it as, you see, the cube root of 27 is a 3. So mean that this is 3. The cube cube root of x triple is x. So I can write all of this as this, then plus. Cube root of 8 is 2. So this can be 2 cube like that. I think you see, when you get this, so 2 power 3 is 27, x power 3 is this, 2 power 3 is 8. Why? I'm writing it in this form. Now it's at my A, this is going to be my A, and this is going to be my B. When I put them there, so I'm going to be having 3x plus 2 into my A, which is 3x, the whole square, minus A, which is 3x, then B, which is 2, then plus a B squared, which is 2 squared. As simple as that. Let's start now. My 27 x cubed plus 8 is going to be, this is going to be 3x plus 2. When you square a 3, you get 9. When you square x, you get x squared. This time this will get 6x. Then plus when you square 2, you get a 4. And so we have factorized that. So it's that this one is unfactorizable quadratic, but unfactorizable because when you solve this, it's going to give you complex roots. Because you see A and B, when you get 4AB, you are going to get a big value compared to B squared. Okay, so now it means that now the whole of my 6 minus 9x over 27 x cubed plus 8 is the same as 6 minus 9x, the whole over. Now this we said is the same as this, plus 2 into 9x squared minus 6x plus 4. Now we can say, now we're going to use our partial fractions here. This is going to be, okay. Now my 6 minus 9x over, I'm doing a lot of writing, 9x squared minus 6x plus 4 is going to be anyway equal to, this is linear because it's power 1, it's going to be a over 3x plus 2, then plus, this is quadratic and we cannot factorize it. So that's why I'm going to say bx plus b, or you can use c, no problem. 9x squared plus 4. So the LCM is this time this, which is here. So now, so our 6 minus x is going to be, when this you get this divided here, remain with this times this, you get a into 9x squared minus 6x plus 4 into, and you get now this divided here, remaining with this, now this times what's up here. Up you have bx plus b into, now when you get this divided here, this goes remain with this times now this 3x plus a 2. As simple as that. Now we have seen how we handle this. To get a, you start the factors missing here is this, so you put this to 0 to get a. So now 3x plus 2, if it's 0, you get now x, but our x is going to be negative 2 over 3. Take this side, becomes negative divided by 3. Now substitute it there. You have 6 minus 9 into negative 2 over 3 equal to, now a into big brackets, you have 9 into x squared minus 6 into, then plus 4, then plus my b, but the whole of this is going to be a 0 because this is 0, as simple as that. So here we are going to be adding a positive 3 divided here, 3 divided here, you get 3 times 2, that is 6. So here I have 4 equaling 2. You see when you square this you get 4, and square this you get 9. So here we have a 4 minus minus, you get a positive. 3 divides here, you get You get 3 divided here, you get 2, 2 times 2, which will be 4, plus a 4. This. So here I have a into a 12, and from here, that our a is going to be a 1. Okay, so after getting a as 1, so you have other unknowns. What can we do? It's that to get this small b, you have to remove this because you know what a is. Now you equate this to 0. So if my x now is 0, I'm going to be adding 6 equaling to a. But my a is 1. Okay, a into this is 0, this is 0, this is I'm reading with 4. Then plus this is 0, so I have b into this is 0, so I'm reading with 2. And so that here my 6 will be equaling to 2. My a is 1, so 4 plus 2b. Taking this side, that my 2 will be equaling to 2b, so that my b will be a 1. So now, if you have that, now you can come and get now the capital B. So capital B, use any you want. The smallest you can use, you see, I can use a negative. If I use a negative, it's going to be there big. We can use 2 any. We use, but not 0, not 1. Okay, let us use a 1. If I say not 0, I mean not 0, and not this x negative 2 over 3 because I've already used them. So you can choose when x is 1. Smaller values so that you don't get big values. When x is 1, here I have negative 3 equaling to my n is already 1 into 1, which is 9 minus 6, that would be a 3, plus 4, that would be a 7, then plus into my b times x, which is 1, then plus a 1, because b is 1, into a 5. So this is going to be, when I take this side, I have negative 10. When I take this 7 this side, equaling to 5b plus 5. When I take this side, I have negative 15. So negative 15, when I take this side, equaling 5b. Such my b is going to be negative 3. So you have everything there. So now you come and write this. Now my 6 minus 9x is equivalent to our a. Our a is what? Our a is 1 over plus 2. Then plus our b. Our b, capital B, negative 3x plus small b, which is 1, the whole over 9x squared minus 6x plus 4. And you can go on to separate it. So now our 6 27 x cubed plus 8 is going to be 1 over 3 plus 2, now minus 3x over 9x squared minus 6x plus 4, then plus this one over 9x squared minus 6x plus 4. And we shall see how we integrate these ones with unfactorizable denominators. Now on part C, I'm going to give you a hint just. You will copy it in your free time. Over x minus 1 into x squared plus 1. So you see that this one is unfactorizable, this one is linear. And you see that now, this one is having a 2, meaning that's now repeated. So how do we handle it? This is going to be equivalent to a over, this is linear, then plus. This is repeated but quadratic. We said if it's repeated, you start with power 1. But remember, this is the inside thing is not linear, it's repeated, and it's quadratic. If it's quadratic, we said the remainder should be linear. So we said this one is going to be ax plus b over, this one is said to start with power 1, x squared plus 1. Then plus. You go now to the next, which will be cx plus d over Now x squared plus 1 into the whole 2. Now if we have 5 unknowns, we need to get 5 simultaneous equations and solve them. So that's how we have these ones. I wish you well.